Okay, so now let's continue with our example. Here we want to find the allowable increase and decrease for the right-hand side. So here I have two constraints. So I have B1 and we have B2, and we want to find the change, allowable increase or decrease. So I'm going to say here plus D1, and here I'm going to say D2. For the final tableau, we place on the coefficients on the slack variable. So x4 is a slack variable for the first constraint. So we place a d1 here. And for the x5, which is the slack variable of the second constraint, we place another d2 here. So now basically what we want to write an equation for x3, which is my basic variable here. It is equal to 6.67 here. I'm just going to use two digits plus 0.667 d1 plus negative 0.33 d2. This has to be greater than 0 because we want to keep x3 as a basic variable. Now x2 is again, it is equal to 10 plus we have here negative 1, so this is negative 1 times d1 plus 1 times d2. So here again we want to have it greater than 0. We have two equations. So now to solve for d1, we set d2 equal to 0, and we take these two equations. So let's start with this. For the first equation, I have 6.67 plus 0.67 d1. So this should be greater than 0. If I take it to the other side, 6.67 divided by minus. Okay, let me just write it here first. 6.67 is greater than, before we do the dividing, I'm just gonna skip one. Okay, let me write it again. So here I have 6.67. This is minus, this is greater than minus 0.67 d1. And now if I divide by, so it is 6.67 divided by minus 0.67 would be, we flip the sign, so this would be d1. Therefore, I have, this is minus 10, this, and this is d1. So therefore, I can simply write d1 is greater than minus 10. So this is greater than minus 10. So basically, we can simply conclude that the allowable decrease for B1 is equal to 10. Now we use the second equation. The second equation, we have 10 minus 1 times d1 is greater than 0. Again, because d2 is equal to 0. So this, I can simply write 10 is greater than d1. Therefore, simply write that d1 is less than 10. So the allowable, again, increase for b1 is equal to 10. Okay, now to do for d2, to solve for d2, we set d1 is equal to what? To 0. So again, using the same two equations, I have 6.67 plus 0.67 times d1. d1 is 0, so this is minus 0.33. d2 is greater than 0. I take it to the other side, it will be 6.67 is greater than 0.33 d2, and we divide by 0.33, which is multiplying by 3, so this is 20 now is greater than d2, therefore d2 is less than 20, and this would be my allowable increase for b2 is equal to 20. Now using the second equation, I have 10 minus 1 times d1, which is 0, and plus 1 times d2 is greater than 0. Again, we take d2 to the other side. It will become minus d2. And then I will multiply by and by minus 1 and flip the sign. So this is 10 is less than d2. Therefore, d2 is greater than minus 10. Therefore, this is the allowable decrease for v2. So basically now we are done. We found what is the allowable decrease for v2, which is equal to 10 from this equation here. And we found the allowable increase for v2, 20, again from this equation. And we found the allowable increase for v1 from this equation. And the allowable decrease for v1 from this equation. Hopefully now this example re-emphasize how we can calculate the allowable increase, allowable decrease for both the objective function coefficients and the right hand side.